bolt to go in. That is the... Everybody in the world touched the pad and it should be used. So I've got the, let's take a little... Hi there and welcome to the Andy Mechanic YouTube channel. Now, a few weeks ago, no, it wasn't even a few weeks ago, it was actually last week, golly, Sam came into the workshop and she gave me a hand stripping down an automatic transmission of a Honda Odyssey. And the purpose of the video wasn't specifically to diagnose the fault of the gearbox. It was really for Sam to get a hang of using tools and to get to grips with getting her hands dirty, basically. And it all worked out pretty well. She did enjoy doing it, and it was great to have her on board. But it has been niggling me for the last few days about what was really wrong with that gearbox. And we didn't really find too much wrong with it as we pulled it apart. And as a mechanic, you know, the fault's in there somewhere, and it'd be good to find it. Now, unfortunately, we were unable to, scan for fault codes and so on whilst the gearbox was still in the car. It'd already been taken out when I was given it. So, we have to revert back to purely an inspection process to try and work out what the problem is, or was, rather than looking at codes and so on. And we certainly can't do any testing in the car. Now, the majority of the parts were all chucked on the bench and all completely out of order, and I haven't got a workshop manual, so I don't really know and really can't remember what goes where. But that doesn't stop us having a little bit more of a look into some of the components that we didn't really inspect properly during the video that Sam took the gearbox apart. And first of all, I'd like to have a look at the clutch packs. Now, this gearbox, and I don't have that much experience in automatic gearboxes, and I'll be completely honest with you, that gearbox didn't have any planetary gears in it. And I always thought that automatic gearboxes, traditional automatic gearboxes at least, have planetary gears, clutch packs and brake bands, and that's basically how they provide the ratios to give the car various gears, basically. Now, these clutch packs, when we pulled them apart with Sam, didn't really appear to have any problems. But when I was rummaging through all the bits and pieces and cleaning out the old gearbox casings of any kind of steel so I can weigh the aluminium in for scrap, pay for a few more cigarettes no doubt, I had a bit more of a look, and well, this is what I found. What I have done is put the clutch packs back together. Whilst I was inspecting them, I was basically working out which of the clutch plates went into each pack, and as I was doing it, I rebuilt them. So that's why currently they're all back together again, because they were stripped down, all apart from one. And the one on this shaft here, we completely forgot about stripping this shaft down. Obviously I was distracted. So why not pull this one apart first, because it might be this clutch pack that reveals the problem. And believe me, I have no idea. I've not pulled this one apart. This is exactly how we left it when Sam left. So we'll get this stripped down, we'll inspect these plates, both the friction and the steel plates, and then we'll move back to the other three clutch packs that were stripped in the previous video, and we'll strip those down and we'll have a look at the plates in those as well, and we'll see what we can find. Also, we pulled off various number of solenoids. We've got these two here and two more here. And I think as well we should be testing these, because these are very common to failing. And but if we've done a scan code, scanned for codes, then maybe one of these would have highlighted a fault on the scan tool. But we can't do that, so we're going to have to go back to basics. Okay, so without further ado, let's pull this clutch pack apart. God knows how we get it off the shaft. Let's have a quick look and see what we can find. Here we go. Right, now I was looking for a circlip on the end here, because basically that's the pinion gear that goes onto the differential unit, and that is part of the shaft. There's no way the clutch pack is going to come off this way. It has to come off the shaft that way, which means that all these gears, and there's a spacer there, look, all these gears must come off the shaft this way. So I was looking for a circlip on here, but there isn't one. So I think Honda have just done one of those on the, you know, the gears tight on the spline. So we'll give it a go, just bashing it on the bench. And I'm not worried about the shaft. All of this is scrap, don't forget. Wow, there goes the hearing. Okay, one shaft. There's the prize. And all this stuff, geez, can go in the box of bits, because, you know, we've already inspected those and there's no broken teeth or anything like that. Oh, there goes the glove. That didn't last long, did it? Okay. Get rid of the shaft. In fact, actually, one of two of you may wonder, how on earth is the clutch pack actuated? Well, if you look down the shaft down there, look, it's got a hole. It's hollow all the way down. And it's got little holes along the shaft. And the pressurized oil, the line feed we call it, is basically through the solenoids, is diverted to wherever it needs to go to do whatever it needs to do. And on the clutch pack, which is the end one here, that will be the supply to actuate that clutch pack. So pressurized oil is fed through that hole and it goes into the clutch pack through that little hole just there. Look, if you can see that or not. Little tiny hole. Get rid of the oil. Yeah, there, look, you can see that now. Little tiny hole in the clutch pack. And that then goes behind a piston. We'll see the piston very shortly. Okay, so first job then is to remove this snap ring. And we've got to find the end, which is just there, look. And then we can hook behind there with a little flat screwdriver and basically just pull it around. There we go. Dead easy. And now we can remove the clutch plates. Super. Right. A wavy washer. Right, so just putting that to one side for now. We've got the outer plate. That's the big thick one. What we're looking for is if we can see some bluing, or if the friction plates have worn away, worn down like a normal clutch would do in a car or a motorbike actually. Then, in fact, let's put them all in order so we're not going to mess it up. There we go, look. Let's put them all in order. Okay. Now what we need is a rag. Okay, so starting at the lowest plate, I'm just going to clean off the oil. We'll have a little look. Now, visual inspection is the first one. Now remember, this car lost drive in one of the gears, and I don't even remember whether it was first gear or reverse gear, but it lost drive completely in one of those gears. I think it was first from memory. Okay, well that's nice and shiny. There's no elements of bluing there, and it's not scored, and it's not worn. So that's a pass. That's okay. Friction plates. Now with the friction plates, what you're looking for is, you know, have the little pads worn down, the friction material, and if it has, then you know, there's more chance of it slipping. And if this clutch pack was to slip, then of course you'd lose drive, or at least some of the drive. It might drive a bit, it'd be revving quite high and not going very fast, not the speed it should be. But again, that looks really good. So it looks like this clutch pack is going to be okay. I don't know which gear it did though. That's the only downside, but you know, I'm sure Eric the Car Guy's video will help you to work out which one's which. So again, not really worn, not scored. And if it was warped, yes, it's a problem, but it wouldn't cause loss of drive. That would cause binding of the clutch, where basically you'd be getting drive even when you're in neutral, because the clutch pack will be transferring some torque. There we go. Right, try and do this as quick as I can, because I do know my videos go on forever. I'm sorry about that. I tend to ramble. Yes, put it in the comments, I know. Okay, again, pass. There is a lot of friction material within the oil. You can see how black or grey the oil is. So something in the gearbox has been slipping. Okay, again, that's really good. It's not grooved or anything like that. There is, oh, is there? It's just the residue of the oil. Hang on. No, there's no bluing on there. That's a pass. Right, last friction plate for this clutch pack. Yeah, again, plenty of material left on there. And there isn't much meat on them when they're new, to be honest, and that looks pretty good. Okay, and then finally, the end plates. And these are a lot thicker. These end plates, these pressure plates. And again, that looks, on this side here, that's the side that runs against the friction material. That's fine. You can even see some of the original machining on there. So again, that hasn't worn. Okay, so that clutch pack is pretty good. So, what's next? Well, whilst we're here, let's have a look at that piston. So we've got here a very large spring, and the job of that spring, it's called a return spring. So when pressure is released from the back of the piston, and that's the piston down here, and we'll see if we can get it taken out for you. When pressure is released, that spring pushes the piston back to allow these clutch plates and steel plates to have clearance so that there's no drag. So what we need to do is quite dangerous, and you know, anything could happen. We've got to try and compress that spring a bit and get this snap ring out. Now normally without the special tools you wouldn't be able to get this put back together again. So there is one possibility. If this pack had been slipping, maybe the seal on the piston was leaking. It could be an O-ring seal, it could be a Teflon seal, and obviously some of the pressure would then be leaking past the piston, and you wouldn't be getting the pressure clamping the clutch pack. So we can have a little look at that, but I don't think this clutch pack's not showing any symptoms for that. So how the hell am I going to get that snap ring out? Let's have a look. Okay, I'm not entirely sure how successful this is going to be, and I don't like to do things before I put them on camera. I like to go with the flow. So I just want to take the pressure off that. We need to push this spring back to give us clearance to get that circlip out of the way. And obviously G-clamps are not the best idea, and I'm sure Honda have got a special tool, 36B, for doing this. We don't have one of those. Now obviously eye protection, good idea, because things can go tragically wrong. And we're going to need some circlip pliers. Get those ready. Okay. Hopefully it won't destroy the camera. These springs can be really powerful. Just do a bit at a time either side. Okay, that might be enough. Let's see what we can get that off there. Go on, you can do it. I think a little flat screwdriver is helpful. Okay. Let's see if we can just hook that over there, look. Okay. Point of no return. And it could just way easy, tiger. God, that was close. Okay. It's probably going to slip off at some point because I've only got so many hands. Should be interesting. Letting on the edge. You can see how hard it would be to put this thing back together again without the right tools. Okay, I think we're not far off. feels a lot less tense now. There we go. Perfect. Genius. So, one big spring, one return spring, off. Okay, let's have a look. Now, usually these pistons will pop out if you give them a good bang on the bench, but this is probably going to destroy the camera, but here goes. Hey, there we are. Super job. Okay, so getting our rag and clean off all the crap. There we go, look. Right. Okay. So, what we've got here is the O-ring seal. Now, it's intact, yes. It's a little bit big. So it's not really a tight fit on the piston. It's actually sort of swollen, which could indicate some contamination. And has it been leaking? I don't think so. If it had been leaking, the clutch pack would have been slipping and the shoes, sorry, the pads, sorry. If it had been slipping, then the discs will be showing wear, the friction discs, and these would have blue marks on them. And these would probably, when they get hot, they get distorted as well, which causes clutch drag. So I don't think it's been leaking, but that's how you'd remove the piston, and you could replace that O-ring. How you get it back together again, well, you'd have to devise your own method of doing that, and don't tell health and safety. Right, so you can see now, there's my pointy stick, a bit more clearly where that oil supply comes in to actuate the piston, push the piston forward to clamp that clutch pack, and you can see down there, look, there's a hole there. This one's got quite a few. It's got another one there, another supply, another one there, and one more there. So it's got basically four ports where that pressurized oil comes in, and you know, it gets trapped behind the piston. The piston has no option but to, you know, be pushed upwards this way and compress that return spring and clamp all those clutch pack components together, basically to cause drive to be transmitted from the drum, the basket, which is what this is, to the inner boss. And just to give you an idea, this is one of the other clutch packs, and I found a piece that fits in the middle. It's probably the wrong one, but basically that's, at the moment, the two components can be driven independently. When that clutch pack's actuated and all the clutch discs, the steel ones and the friction discs, are clamped together hard by that pressure, by that hydraulic pressure, then the whole thing would turn together as one unit and it would transmit the drive. And the pickup is also reasonably progressive as well. It's not a sudden harsh bang into gear. It's actually got a slight progression to it, a bit like a synchromesh. Right, okay, so that clutch pack, which we've now stripped down, was a pass. I think that's okay. I don't think it's going to go back together again, the O-ring, but we'll see. Oh, there we are, look. Just, maybe. There we are. Okay, and then what went next? Well, that wavy washer went in there. And then we had a steel disc. And then a friction disc. Wow, putting it back together, I have no idea, but anyway. Steel disc. Friction disc. Steel disc. Friction disc. End plate. In there, look. And finally, okay, we're not bothering to put the return spring in. I know we're missing that bit. You guys can work that bit out. And then, of course, the little snap ring just goes in there. And they're usually pretty easy to put in. When you're not filming it, they're very easy to put in. Right, there we are, look. Cool. Done. Okay, so that one was a pass. I'll just stick those other bits on top. Right, so we'll get rid of that one. And let's do, this is the first clutch pack that we pulled apart. This was right at the top of the gearbox, and it was outside the main area, probably fifth gear, probably, no guarantees, could be wrong. Right, so we get rid of the snap ring. Like I say, I put all these back together just so that I had an idea of what went where. Right, so basically an identical clutch pack. Now this one is missing the wavy ring because I didn't bother to put it back in again. And we've got here the main outer and a series of friction plates and steel plates. Right, so let's have another little look and see if we can find anything wrong here. Look, so give them a good clean off. Now if you wanted to find out if these plates were warped, i.e. not flat anymore, then you need really an engineer's flat plate and some feeler gauges to do that, or a sheet of glass. You can use a good thick sheet of glass, will also do the same trick. You might have some glass kicking around that you can use. Right, okay, and this is one I spotted when I was quickly running through. I'm sure there'll be some more examples of this, but can you see here we've got little burnt areas, little blue areas here, and there's another one down here, and quite a patch just here. Now that's an indication that there's been slippage in this clutch pack, and you see there, look, as well, where it's been getting very hot on the metal. Another one there. Let's have a look and see what the friction plates look like. And you can also usually tell if you smell them, and if they smell burnt, it's usually an indication that they've been slipping. And all these clutch packs do look the same. They look like the friction plates are all the same between them. So what I might do is just get the verniers out and measure the thickness of what we can call a known good, which is in that previous clutch pack we just stripped, and this one, because if you look on here, this friction material is pretty much worn away completely, and we've got big chunks, I don't know if you can see that or not, but we've got big chunks missing around here. So this clutch pack, basically, these friction plates are worn out. This side's a lot worse than the back side, but if you also look on the rear and compare the colour of the friction material, this is a lot more black. Let me just pull out a friction plate from the previous pack. Hang on. So now if we compare one that looks good to this one, you can see the difference in colour. If we turn it over, you can also see, you know, just how much deeper these are. And I'll get the verniers now and we'll do a quick measurement. Now remember, we're doing all of this without the use of a workshop manual. It's just using common sense. So a known good friction disc, we've got there at, can you read that okay? Yeah, look, 1.94 millimeters. This one, however, considerably thinner at 1.61 millimeters. So that's clear indication, and you can feel it with your fingers. There's hardly any friction material left on this side. Okay, right, moving on then. So we know that the friction disc, or that one, is quite badly worn. Now, obviously, if it's the same for all friction discs in the pack, and some packs have a lot more discs than this, then the compound reduction in pack thickness is going to be quite significant and probably way outside spec. But again, the manual will give you spec. Wow, okay, look at that one. So here we've got some really good indication that this disc is probably warped, actually. Hard to tell without a flat plate, but we've got some real bad pickup in this area here. And around there we've got some bluing. And again on this side here, look. So again, it's all quite badly damaged and irregular. That's what we're looking for, irregularities on that surface. So that's probably warped bad. Now, like I said before, warpage wouldn't cause slippage, it would cause drag. So when the clutch pack is released, basically because there's warpage on the steel plates, they basically still make contact and have some pressure against the friction plates, and therefore they transmit a bit of drive when they shouldn't be. Okay, so what's this one measure up at? Chances are the original spec is 2 mil. Oh wow, even worse. So this one has worn on both sides quite significantly. And we've got on there 1.48 millimeters. Yeah, there's hardly any material at all on this side. And again, this side here, it's actually been ripped away from the surface. So we've got no friction material here at all, and there's a little tiny slither left on this side. So again, that friction plate is completely worn out. Okay. And again, same old story, probably even worse actually on this one. On this steel plate, we've got more points of pickup around here and all around this side as well. So there's definitely been slippage. There's been slippage because potentially the friction plates have worn out and it's been unable to grip. The coefficient of friction between the friction plate and the steel plate has changed because the friction material is pretty much all gone. Okay, and what caused that? Hey, who knows? You know, did it start to slip because there was reduced pressure, and then because it was slipping, it then wore out the plates? Or did the plates just wear out through normal use, and then it caused slipping, which then caused the overheat? One will never know. One thing we couldn't do, which I would have liked to have done, actually, but it's already in bits, was to measure up the oil pump of this gearbox and to see if there's excessive clearance in the oil pump. And if there is, then that potentially could be the reason why these plates have been slipping, you know, because there's been reduced line pressure. But the first clutch pack we pulled apart was fine, so it possibly isn't down to line pressure. Okay, otherwise all the clutch packs will be affected, I think. Okay, again we've got signs of the friction material being ripped away from the metal backing on there. Try not to take too long doing this. Hopefully you'll be able to learn something from this. I know I am. Like I say, I'm not that good at automatic gearboxes, to be honest. Okay, and again you've got very clear points here of bluing on the disc, on this, the final thick plate, around here, here, all around there. And again, if we measured that up on a engineer's flat plate, we might find that it's even a bit warped as well, and that's why it's got points of high pickup. Okay, right. We're going to take the piston out. No, we're not going to take the piston out because I can't be asked to take that circlip out. But you've seen how to do that. Okay, let's move on to the next one. Get rid of all the bits. Okay, now this one we did strip down with Sam. It's a double-sided clutch pack, so basically it's just two made out of one piece. It does the same job. They've got independent centre bosses, I think. Could be wrong. Find out. Okay, so circlip out, snap ring. So easy. Right, again, the spring down the bottom, that wavy spring is missing. I didn't put that back in, but it's not really part of the pack. Okay, stick that to one side. What have we got going on here? Oh, keep it in order, Andy. Keep it in order. Okay. Oh, this one looks pretty good. Yep, that's fine. No signs of bluing on there. Now, looks pretty worn. Okay, let's have a little measure up. Not quite as worn as the last one, but 1.72. So it is still considerably less than the good ones that we found in the first pack. Yep, that one's fine. That one doesn't look too bad. It's got some slight glazing on this area here. Again, indicating it's probably been slipping at some point. And yeah, not too bad. 1.8. Yep, steel plate's fine, no sign, no high points on there, no overheating points, no bluing. Last friction disc, 1.74. Now whether that's in spec or not I don't know, but it doesn't look too bad. And of course the final plate, steel plate, the end plate is fine. Okay, so that's that set done. And if we flick it over, we'll do the other set and see what we've got in here. This is the final clutch pack now. Okay, again, wavy bit missing, that's gone somewhere. Being a big pile of bits, no doubt. Okay, well that one looks okay. Yep, doesn't feel too bad. Yep, 1.81 again. Ooh, what have we got here? Alright, so again we have got on this steel plate some bluing with the plate again, indicating that it has been slipping. Okay. Now when they're reconditioning these gearboxes, if they ever bother to do recondition these things, they're probably not viable to do actually, probably just go and get another one. But they always put new clutch packs in them, new O-rings, new seals and everything, so they probably wouldn't even bother measuring these things up, they just go straight in the bin. A bit of glazing again on there. Thickness 1.84, 1.83, there we go. Right, last thin steel disc, steel plate. Oh yeah, definitely. That's been getting pretty hot. You can see all around here, look, all the way around we've got bluing, both sides. And it's probably warped, and this will be a high point here where it's rubbed the bluing away, just there, here and here. Oh yeah, and there, look. So that most likely is warped. You can't tell by looking at it, you've got to put it on an engineer's flat plate and then look for gaps with your feeler gauge, just like when you're checking your head for warpage really. Okay, right, last friction plate of all the packs, again 1.83. Doesn't look too bad. Okay, and then the end plate, has this one been slipping, do you think, or showing signs of slipping? Because let's face it, if one of the steel plates is slipping, then it indicates that the whole pack is slipping. You can't have one slip and not the other because they're all mechanically linked. Okay, so yeah, that actually looks okay, but don't forget this is a lot thicker and it can cope with more heat, and certainly before it warps anyway. Right, so there you go, that's a quick run through of all the clutch packs, and we found one that very clearly was a problem. So there you go, we did find a problem, didn't we? And I definitely overlooked that when I first took this apart with Sam, and you know, you can see very, very clearly when you put them all together where you've got, you know, all the points where it's been slipping. We've got friction plates that you know, that are a lot thinner than they should be. The friction material is pretty much worn away. We've got steel plates that are showing overheating because the clutch has been slipping, and they're showing signs of high points, which indicates warpage. I'm not going to bother measuring it, you know, don't have time for that, but you know, this is junk, and it's my bet that it was this clutch pack that was slipping. Now once they get to the point where they're slipping too much, there's not enough transfer of drive, then the car will remain stationary and it'll just spin. You know, there's just not enough clamping force in the clutch pack to transmit the force, the driving force, down to the wheels. So now that we know that this clutch pack, all these bits here that I've just shown you, is the only one that's significantly been slipping. So this is a lot worse than the other ones. Some of them show no signs of any problems at all, which indicates that the oil pump in the gearbox was fine. The line pressure was fine because it was okay for the other clutch packs. Why don't we, putting myself at massive amounts of risk again for you, I'm going to remove the large return spring on this clutch pack. I'm going to take the piston out. I just want to double check that the O-ring on that piston isn't broken, because if it is, then of course that line pressure would be leaking out. You could also look on the shaft as well that this clutch pack is on to make sure that any kind of Teflon seals or O-rings that are on there again are intact. And you can see here, look, this is an example, it's not the shaft of that clutch pack, but you can see here you've got those O-rings, and it's really important that those O-rings or Teflon seals, whatever they are doing their job, because again the line pressure will leak out through that, and you'll have drastically reduced pressure within the clutch pack, and of course that's going to cause it to slip. So you need to have a really good inspection, try and work out what's going on. And it's normally a wearing component that will fail, you know, O-rings, friction plates, and it might just be old age, you know. If it's, I think this car done about 380,000 Ks. Again, I'm only going from memory. If my student is watching, then please put in the comments how far the car went before it broke down. Okay, so next job is to mount this back in the vise, find those two G-clamps and remove that circlip so that we can then get this return spring out of the way and get the piston out. Here we go. This could all turn to custard. In actual fact, it already has. Andy is an idiot. I've got to put the snap ring at the top so I can get to it. Right, are we there? Nearly. There we go, look. Perfect. Right. Action stations. Right, that's one. Living on the edge. We're really pushing my luck doing this twice, I think, aren't I? Okay. Should be enough, he says. Probably won't be. Whoa, the G-clamp's just in the way on that side. See if we can get that side out. There we go. Ugh, so close. Way, I saw that move. There we go, that's what I wanted. Okay, let's just release nice and slowly now. Try and keep it as even as we can. Hey, stay on there. Doink! There we go. Okay. Just survived. Right. There's the bits. Okay, let's see if we get that piston out. Okay. Oh, that was easy. Sometimes they're really hard to get out. You've got to bang on that buggery. Okay, so we're looking to see if that O-ring has failed, or it's got a crack in it, or it's damaged, and that could be an indication. Right, little screwdriver. Shouldn't take a lot to get the O-ring off. It's pretty slack. Okay. Well, that one, if you just run your nail through it as it goes past, you usually find any kind of rips or tears. Actually feels pretty good. Now don't forget the inner O-ring as well. You've got a secondary seal, don't forget, as well, where it seals on the inside. Let's have a little look at that one. Nope, that one seems fine too. Okay. Well, there's no obvious reason why the friction plates, I think basically it's just worn out. So the friction plates have all worn down through use, you know, and it might be that this could be, you know, I think it was first gear or reverse, and they're both a high torque gear. So this clutch pack is transferring more torque than the clutch packs that do the higher gears. And the more torque, the more chance of slippage. More chance of slippage, then of course you're going to get more wear. So these are doing a lot more work than for a gear further up the gearbox. Plus, you know, you're setting off from standstill. If you learnt the car as a teenager and they're hard on the throttle, then it's going to be a bit harder on this particular clutch pack. So I think it's just worn out basically. We've not found anything obviously wrong. Oh, not obviously wrong. We found something that's very obviously wrong, but not a particular primary fail, so to speak. Nothing to really cause it to start slipping. So there you go. As regards the 4 clutch packs in that gearbox, only one was in really bad condition with extremely badly worn, or very worn out in fact, friction plates and burnt steel plates, and most likely distorted steel plates as well, due to the heat caused by the slippage. So we went a bit further. We had a look to see why that particular clutch pack might have started to slip if it hadn't just been normal wear and tear. Had a little look at the O-rings on the piston of the clutch pack, and both those 2 O-rings were good. So my opinion is that I think that clutch pack was first gear. Correct me if I'm wrong. First gear carries more torque, does a lot more work, still only gets the same line pressure as all the rest of them. So it has more chance of slippage. It's going to wear more. You know, you always use first gear to set off. You may not always make it up into top gear. Especially if the vehicle's around town. Stop, start, first gear. So yeah, I think that clutch pack just wore out. And then the vehicle lost first gear. There you go. Okay, well there are still 4 solenoids to test. So we should do that really, shouldn't we? Right, now these will be actuated by 12 volts battery voltage. So I need to rig up a power supply, and we can check first of all to see if they click. And if they click, then it's an indication that the armature is moving around. And we can try and rig up some way of making sure that they only do what they're supposed to do when they're actuated. Now, some of these solenoids might allow, and we're talking fluid flow now, they may allow fluid to flow when they're actuated and not when they're not actuated, i.e. no voltage supply, or it could be the other way around. There might be fluid flow when they're not actuated and then no fluid flow when it is actuated. We won't work that one out until we start playing around with them. Okay, I'll get set up and we'll see what we can do. See what we find. Here we go. Okay, now this is the first. I've got my little 12 volt power supply down here. It's turned off at the moment. It's actually variable power supply, it's set on 12 volts. And each solenoid has only got 1 wire. Now that tells us that the other end of the winding that's in here will be down to ground. That's why it's important your gearbox is grounded properly, I suppose. Okay, so green is my earth. We'll pop that onto there. And all we're going to do first of all is listen for a click. So we'll turn the power supply on. There we go. And all we need to do is, so we've got the black wire, so that's this solenoid here. We can just tap that onto there. There we go. So we can hear it operating. Then we'll try the green wire, which is this one here. Well, you can even see it on there, look. Pretty cool. That one doesn't sound quite as powerful, does it? And what we can't do is remove the solenoid from the casting because it's all crimped over. If either of these two were to fail, you'd have to replace this whole component. Very expensive. Now we do also have, where's my scriber? There we are, look. Obviously you've got seals in here as well. We've got one big moulded seal, so we can hook that out of there. And it's got little filters, little gauze filters on there as well. I wonder if we can see a bit more now. Okay, so how could we tell that that's working? Because basically what's happening is you've got a channel that runs through, a drilling that runs all the way through the solenoid, and at the moment, you know, we don't know whether that is connected to that and allows flow, or whether it's not connected. So what I'm going to use is a spray. I'm going to go and find my WD-40. We'll mount this in the vise, we'll actuate it, and we'll see if we get a change, whether it's flow or no flow when there's voltage compared to when there's no voltage. And there should be a difference, there should be a change. If there's no change, or obviously it's leaking, then we know that the seal inside here on the armature is worn out. Cool, let's do that. Okay, so we've got our earth on here. I've not connected the power feed just yet. There we are, look, so it's off. And we're just going to see if flow is allowed to transfer from this port to here. So it should either be sealed or not sealed. That's pretty sealed. Let's try this one. And again, that's sealed. Okay, so let's pop actuate. So we've got the, oh, I called it a black wire, look, it's not, it's blue with a yellow tracer. Damn. Okay, so we'll actuate the blue with the yellow tracer, which is this one. Get some power on there. Just turn the power supply back on. There we go. So that's now actuated, so we should now see flow. There we go, look. Cool. So that one allows the fluid to flow from the inlet to the outlet, or vice versa. I imagine that's the one with the gauze, that with the inlet to the outlet when it's energized. This one is not energized, no flow. So we'll energize that one now, which is the other wire. There we go, and again we should get flow. There we go, look. Magic. Easy way to test that it's working. Great job. Okay, so it's gone cold. Damn. So we've checked the actuation of these two solenoids, and we did a little click test first to see if we could hear the noise of the solenoid. We did. So then we worked out how to test. Came up with a really simple test to see if the actual valve inside that solenoid unit is allowing flow when it should, and when it shouldn't allow flow, there's no flow. And you know, using something like a compressed can of lubricant, what's the name? You know his, is a really simple way and something that most people will have around the workshop. So that is a pass. Now what we have got left is these two solenoids, and again there's going to be an inlet, and this one's got a little gauze on it there, so it's probably an inlet. But these have got two wires, which tells me that they could be double acting solenoids. So they might still be grounded, and there might be two windings inside there. So it pushes the plunger one way to open one valve and the other way to open another valve. Because let's face it, there's actually three. Where's my scriber gone? There's actually three ports. We've got one here, and one here. And again, this solenoid here has got 1, 2, 3, and it's got that gauzy thing there as well. So there's actually more going on with that one. And we can't ball bearing. We can't take the solenoids off because again, if you look closely, they're actually crimped over the aluminium casting. So again, if either of these two were to fail, you'd have to buy a complete new unit. Honda would be laughing, wouldn't they? Okay, well, let's get it in the vise. What was it made by? Denso. You can just make that out on there, look. It's got, you probably can't read it on there, but it's got Denso just written just up there, look. Okay, we'll get it in the vise and, well, let's see what we find. Here we go. Okay, so I've put the ground on the casing again, just to prove, to see if these are actually double acting solenoids or not. I don't know, I haven't got a manual. I'm just winging it basically, using a bit of logic. So we'll turn the power on. I'm just going to touch it into one of these terminals in here. Very hard to see with the camera in the way, but okay, so that's one, nothing. The other one, nothing. Let's try this one. Nothing, nothing. Okay, so they're not double acting solenoids. So now we can put this ground wire, it doesn't really matter which way around they go, onto one of the terminals, and then we'll try it on the other one. Oh, there we go. Cool. So obviously that's this one here working. And we'll just try it on the other one, just doing the noise test first, because there's no need to do any more tests that don't make a noise. There we go. Okay, so they're both actuating. You can hear the armature firing basically along the solenoid. So now we need to work out what's going on. So while we're wired on this one, let's just try okay, well there seems to be no flow anywhere. Nope, nothing going on there, so we'll actuate it and we'll look for the change. Hey, what's going on there, look. Okay. Right. Okay. So now we should get flow. We're definitely getting a few bubbles up here, but there we are, look. Let's just mop that up out of the way. I need some more WD-40 at this rate, aren't I? Yeah, I suppose I could use compressed air, but it's a bit harder for you to see on the camera. There we are, look. So we've got flow between these two ports here when it's actuated. There you go. And when it's not actuated, we've got, hopefully, no flow. Okay, so that's working just fine. Very happy with that one. Let's try the other one. There we go. So I'm guessing it'll be these two ports again. So we should have flow going between these two. Oh, try it that way around. We do. See, it's not that obvious. There's a bit of a kickback going on. And if it was sealed, if I could seal it off, it'd be even better. But if you watch here, you should see some bubbles coming through. In fact, let's move the camera for you. Now you can see what's going on, can't you? Okay, so we're looking for bubbles just coming out of this port here while it's actuated. There you go, look. Okay, so conclusive that that one is also working correctly. Let's try it once more for you just to prove it. Okay. Here goes. You ready? So you're looking at this hole here. Excellent. Jeez. WD-40. I need to get some sponsorship, don't I? Okay, so both these two solenoids are working correctly. I'll do that one again just whilst the camera's in place, and then you can see that one working as well. Right, pop that one on there. Get the live. Stick that on there. Right, so again, we should see bubbles coming out of here. Brilliant. And I'll de-energize it and we'll just check that we don't get any bubbles. Now it will be, if I get the airline out, we could actually just check that there's no leakage at all, much higher pressure. So I'm going to de-energize it now. So that's the relay off, solenoid off, sorry, solenoid off. And we've got absolutely no bubbles whatsoever coming through here. That's conclusive. Good enough for me. Oh, it really is cold now. Okay, So we've just basically very quickly and easily tested the two pairs of solenoids, and these are mounted on the outside of the gearbox, very easy to replace without having to remove the gearbox. And you could even take them off and just test them on the bench. Bench testing is always a good idea. So we've covered all 4 clutch packs. We found a dodgy clutch pack which was pretty much worn out. The friction plates had worn out, the steel plates had they indicated warpage and had overheated, had points of high pickup. And we've checked all 4 of the 12-volt solenoid valves on the outside of the gearbox, and they were all a pass. So personally, based on all the other inspections that I did during the video with Sam, one-way clutch was working. And I had a quick glance at the oil pump and it looked pretty good. There was no signs of scoring as we pulled it apart. My verdict, my diagnosis on this gearbox is that the first gear clutch pack, I think it was first gear, it might be in reverse, I just don't know, basically had just worn out. The friction plates had worn down to the point where they started to slip, and then it all went to custard from there onwards. And the car had done quite a high mileage, so it sort of stands to reason. So there you go. I hope you found the video helpful. I hope you found the information about how to check clutch packs, how to strip them down, how to inspect them useful, and of course checking these solenoid valves at the end of the video too. All simple stuff, and again, I haven't got a workshop manual. I'm just using logic to check these components. And if you've got more experience than me, and most of you will have, I'm sure, on stripping down a Honda Odyssey automatic transmission like this one, and you want to help contribute and help spread the knowledge, then please feel free to add in the comment section anything you like. Away you go. You'll find me on Facebook, Instagram, Google+, and Twitter. Feel free to communicate through any of those portals, but I would prefer comments on YouTube first call, as that's where the videos are. So if you ask a question on there and I answer it, then people don't have to hunt all over the internet trying to find responses to various questions. If you'd like to subscribe to the channel, click on subscribe. You'll see a little gear icon turn up, click on that, and then you can click the box, tick the box, and turn on notifications. Then our friends down at YouTube will send you an email as and when I upload any new videos. Right, well, that's probably about it really, isn't it? I now need to go and have some lunch. All right, crew, see you next time. Cheers, over and out.